Hey everybody, Mrs. Bianchi here. We're looking at number 10, which historically has given a lot of students a little difficulty. So let's go over it. Brent knows that the six-digit number he uses to open his computer is the prime factorization of 5005. If each digit of the code increases from left to right, what is his code? So if we have to find the prime factorization of 5005 to get started on this, I think that's our first strategy. Now, we know using our divisibility rules, we have to think about what might go into this. And we know that 5 would go into it because the last digit ends in a 0 or 5. But you probably don't know what the other number is, right? We don't know. It's not mental math. How do we find it? We have to divide 5 into 5005 to get that number. So to speed things up, I'm going to use my calculator. I'm going to take this number and divide it by this number. And we get this number. So let's write that number down. 1001. All right. Now, how do we know whether or not this number is composite? So we have to ask ourselves, might some of these numbers go in? Might some of these numbers go in? And especially, might there be a prime number that goes in? So, like, does 11 go in, for example? So how would we know that? Now, I think I have open somewhere on here. I think I have a list of prime numbers. And even if you don't have a list, you can always Google. If you just open up a Google and put list of prime numbers, and we can even go, like, they go up to 10,000, right? So if we kind of look at the 10,000 list and see if that number is on it. So do you see the number that we were looking at on the list? Say, hover around here. See, it's not on it. So that means that something must go into it. So if something goes into it, what's the something? Well, we have to start dividing it by another number to figure out what that other something is. So if we don't have a calculator and we have to start dividing, we could consider our divisibility rules, but also let's look at the answer choices, because remember that these are representing the digits of the code. Now, numbers that I'm seeing in here, I'm seeing numbers like 13, 15, and 17. This might be 11, 13, and 57. This might be 9, 11, and 13. So how about we try dividing this thing by 11, which is a prime number, by the way. Let's take this number and divide it by 11. So this number divided by 11 gives us 91. So here's what we know so far. We know we have the 5, and we know that this number times 11 times, and let's look at the calculator again, it was 91. 11 times 91 equals this number. All right, now is 91 on these are on the prime number list. Is this on the prime number list? Might something go into that? Now we can look at our divisibility rules, or we can go back. Let's see if 91 is on the list. And if we look, see, I see 89, I see 97. 91 is not on the prime number list. So that means that something must go into it. Now, when we think about what might go into it, we can try some of the strategies like adding the digits, seeing what might go in. But let's again look at some of the numbers here that they're suggesting. What if we try, I keep seeing this number 13. What if we try dividing 91 by 13? Let's try that. 91, let's clear this thing. 91 divided by 13. And let's see what we get. We get 7. So 91, we divided it by 13, and we got 7. So that means that 91 is composite. 7 times 13 does equal 91. Let's bring the other numbers down, and let's ask ourselves, this row that we have right now, we have a 5, we have 11, and we have a 7, and we have a 13. Are all of these numbers on the prime number list? In other words, do they have only one in itself as factors? So we have the number 5, we have 11, we have 7, and we have 13. So let's take a look at the list. We have 5, right? 11, 13, 17, all on the prime number list. So this is our prime factorization. So now we have to think about the wording here, because it does say if each digit of the code increases from left to right, what is his code? So let's just look at the digits. We have a 1 and we have a 1, right? Let's write that down, a 1 and a 1. We have another 1 right here. We have a 3. We have a 5, and we have a 7. So these are all the individual digits written out, increasing from lower numbers to greater numbers. Now look at the answer choices. Does what I have written here match any of the answer choices? And if so, then you're going to go ahead and pick that.